In the last session, we have seen the operation of a transistor as an amplifier. We have discussed the common emitter configuration of a transistor acting as an amplifier. The figure here shows a common emitter amplifier used in a physics or an electronics lab for studying the different parameters associated with the transistor and the transistor amplifier. From the circuit, we see that the input signal is applied across the base and emitter terminals. This is the base terminal and this is the emitter terminal. The input signal is applied between the base and emitter terminal, and the output is taken across the collector and emitter terminals. This is the collector terminal and this is the emitter terminal, and the output is taken across these two terminals. The emitter base junction of the transistor is forward biased. You can see that this is the base and this is emitter. This is the emitter base junction, and it is forward biased using the voltage source, the DC voltage source VBB. And the collector base junction, this is collector, this is base. The collector base junction is reverse biased using the DC voltage source VCC. Now we can see that VCC, VBB, RC and RB, these together determines the quiescent point of the transistor. This is VCC, VBB, we have RC and RB. These together determines the quiescent point of the transistor. Then we have two capacitors, C in and C out. The C in and C out are called the coupling capacitors, which blocks the DC and allows the passage of only AC. And this isolates the DC signal from the AC signal. This is very, very important. Now, we may write the instantaneous values of the currents and voltages. We have the base current. The instantaneous base current is the sum of DC base current and AC base current. Likewise, you have IC equal to IC plus IC, the DC component and the AC component, and we have the emitter current IE as the DC emitter current and the AC component. Likewise, we have the collector emitter voltage as the sum of the DC value and the AC value. Now we have the VCE, IB, IC, IE. These are the DC values which are called the quiescent voltage and the quiescent currents. And the AC values VCE, IC, IB and IE are the AC voltage and the AC current. Then what remains is a source resistance RS. Then we have two other resistors RB and RC, the base resistor and the collector resistor. A practical amplifier circuit is not like this. In the previous case, we have two separate DC sources VCC and VBB. It is inconvenient to use two separate DC sources in a circuit. So what we do is we'll be using a single DC source, and from that single DC source we will derive voltages for VCC as well as VBB. Such a circuit is shown here. What you are seeing here is the common emitter amplifier with base bias. We have already studied this circuit. Now we shall study this circuit using the AC analysis and DC analysis. Let's start with the DC analysis. For this purpose, the input AC sources are removed and the capacitors are made open. That's how we do the DC analysis. Then we can see that VCC equal to IBRB plus VCE plus IER using KVL. VCC equal to IBRB plus VCE plus IER. From that we can find the base current as IB equal to VCC minus VCE minus IERE by RB. We know that VCC is much greater than VCE because VCE is about 0.65 volt. So we can neglect VCE. If we neglect VCE, then IB becomes IB equal to VCC minus IERE by RB. And we have the value for IC as beta IB, where beta is the DC current gain. And we know that the value of the emitter current is almost equal as that of the collector current. So we can write it as IE is almost equal to IC. We will analyze this circuit using the AC method. The AC analysis goes like this. When you want to do AC analysis, the first thing is you remove all DC sources and you short all capacitors. When you remove all the DC sources and shorting the capacitors, the circuit becomes this, where you can see the source input. This is the AC input, which is appearing across the base resistor and creates a base current IB, which further creates the emitter current and the collector current, and the output is taken across the collector resistor. AC and DC parameters are used to find the amplifier parameters. So the main purpose of doing AC and DC analysis at this point is to find the amplifier parameters. A more robust or more vivid AC analysis is obtained by replacing the NPN transistor here with a small signal model in which the input region is represented by an AC resistance and the output region is represented by a current source. When we do that, the circuit becomes this. This is the input AC voltage, the source current from which we get the base current, and this is the base resistance, which is grounded. Then we have an input resistance and input voltage, and the output side we have a current source, and this is a collector resistance across which we take the output voltage. Let's check the different parameters involved in this diagram. The first one is the base resistance that we have discussed here. We have the source voltage here. Then beta RE prime, in fact. Beta RE prime is the AC resistance of the base emitter junction, which is seen by this AC signal Vs. This is also represented by the symbol Ri or R in base. Then we have beta, which is the common emitter DC current gain that we have already discussed. Then there's another term, RIS. The beta Re prime represents the AC resistance of the emitter base region seen by the input signal. This resistance, which is known as the input resistance Ri, does not include the effect of the biasing resistor Rb. So when you take into account the influence of Rb as well, there is another resistance RIS or R in stage, which is the combined resistance of Rb and Ri. This is otherwise called the input stage resistance. Finally, at the output side, we have beta IB, which is the collector current, and beta Re prime is very much less than Rb. Beta Re prime is the resistance which is seen by the input signal at the base, which is very much less than Rb. So what happens is almost all the current which is coming from the source will pass through this base emitter region or through this beta Re prime. A very small fraction of the current will pass through Rb. Now we shall derive the different parameters involved in the amplifier, and these are the parameters. The first one is the input resistance, Ri. Input resistance is the ratio of the input voltage to the input current, which is Vb by small ib. The base voltage is nothing but the input voltage Vin by Ib, but the input voltage is the input current times the input resistance. The input resistance is beta Re prime. So we get the result as beta Re prime. Mind you, in calculating this input resistance, we have not considered the resistance which is connected at the base. Now, the input resistance of the amplifier stage. In calculating this resistance, we are considering the base resistance also. So that resistance is RIS given by RB parallel beta Re prime. You can see that here RB is parallel to beta Re prime. So the effective resistance will be the resistance given by the parallel combination of RB and beta Re prime. So RIS or the stage resistance is RB parallel beta Re prime. We know that beta Re prime is very much less than RB. So The parallel combination will have a resistance which is less than beta Ra prime, or we can make it almost equal to beta Ra prime. So RIS is nothing but Ri. Then comes the output resistance. The output resistance is the resistance at the output, which is there is no other resistance other than the collector resistance. So Ro equal to Rc. Now we will calculate the current gain. Current gain is the ratio of the output current change to the input current change, which is IC by IB, and we know that IC by IB is small beta. Then comes the voltage gain. AV is the output voltage to input voltage ratio, which is ICRC by IBRI. This is the output resistance. This is the output input resistance, output current, input current. But IC is beta IB and Ri, the input resistance, is beta Ra prime. Substituting this, we can cancel beta and IB and we get RC by Re prime, which can be further modified as RC by Ri by beta, because Re prime is Ri by beta, and we get beta RC by Ri. Finally, the power gain of the transistor, power gain of the amplifier, common emitter amplifier, is given by AP is current gain times voltage gain, and it is beta times RC by Ra prime, and again substituting for Ra prime we get beta square RC by Ri. So this is the discussion on common emitter amplifier, and this is how we calculate the different parameters of common emitter amplifier.